Good morning, good afternoon, good evening. This is Michael Jansen. I am the chairman and CEO of Cityzenith. Thank you very much to the Future Digital Twin Conference organizers for inviting us to this event. It's been a wonderful opportunity for us to interface with other digital twin enthusiasts around the world. And of course, it was our pleasure to be a gold sponsor this year. Cityzenith is in the business of making digital twins with an emphasis on highly efficient, zero emissions cities, buildings, and infrastructure. And I'm going to talk today to you a little bit about what exactly that means. By way of quick introduction, Cityzenith was founded in 2009 by myself, one of the original creators of Google Earth, and some of the original founders of Revit Technologies, a famous BIM, or Building Information Modeling company that was acquired by Autodesk in 2002. We're privately owned with offices in London and Chicago and New Delhi. There's about 40 Cityzenith staff now around the world in North America, in Europe, and of course in the Middle East and in Asia. And we have now deployed projects around the globe, in Europe, in America, in the Middle East, and again, in Asia. The company is again privately funded. We've raised about $10 million to date, and we recently launched a Regulation A+ semi-public offering, which is now active. So what are exactly urban digital twins? We've heard a lot today about digital twins generally, especially as they impact the oil and gas sector. What was an urban digital twin? So what we specialize in, or urban digital twins, are virtual replicas of the buildings and infrastructure and all the physical assets in cities. And they're fully interconnected with all of the data in and around them. These digital twins can provide actionable insights for optimizing a wide range of major city and city planning functions, including design, engineering, and then, of course, construction and ongoing operations of cities, from design, as they say, through demolition. Increasingly, digital twins are being deployed to help simulate and predict various types of outcomes, and their users have expanded to include not just architects and engineers, but asset owners, field operators, facilities managers, executive leaders, and even tenants and citizens. Recently, Forbes magazine said that by 2025, 500 major world cities will rely on digital twins for daily operations. So what are the issues affecting cities today that require this type of digital twin response, if you will? Well, we need to build the equivalent of, or rebuild, that is, 10,000 new cities by the year 2050 just to keep pace with expected population growth. Today, data, as we all know too well, is often siloed in pockets of intelligence and individual city departments. And there's a plethora of disconnected systems and proprietary applications out there that are required to design and construct today's complex projects with real no common threads between them. So we've got an industry which is full of myriads of tools that's generally unwilling to share data, and that has yielded a decades of ill-informed decision making, especially as we emerge from COVID. But there are new things happening on the horizon that we have to pay attention to too. We're now in this era of building cities back better. So that means building cities back sustainably. And so hence decarbonization has become a big priority for cities that are building back post-COVID. So our approach as a company is what we call an open platform approach. And this approach allows us to kind of take a kind of non-proprietary view of things and integrate almost any type of third-party data, whatever it might be, whether it's 3D models or GIS or IoT data, et cetera, even public data sets that might be static things like Energy Star reports or plan development records, and then of course third-party software systems, all into this kind of common framework, this kind of sim city, but for real cities, if you will, that allows us to do a bunch of different things, from just visualizing this data and being able to present it, to being able to run analysis and simulation at scale across an entire city and all of its neighborhoods, to things like process and systems management, to simply just dashboarding, and of course to being able to ultimately control, what we call bidirectional control of IoT systems using the actual digital twin itself. So, our clients tend to hail from the energy services industries, the infrastructure world, and the real estate world, and a little bit also from government. They include major architecture and engineering firms like Foster and Partners and Perkins and Will and W.S. Atkins, and they include the Department of Defense in the United States. They include major real estate companies like the Orlando Sports and Entertainment District, et cetera, et cetera. These are all the types of entities now who are kind of getting in on the act, as it were. And the kinds of things that we've worked on over time range to include master developments, seaports, smart buildings, smart cities, of course, smart grid projects, campuses, airports, infrastructure projects, and now more and more commercial real estate. And I'm going to walk you through a couple of these to give you a sense of what some of these look like in action and to describe a bit about the use case. So one of our earlier projects using a digital twin at scale was of the city of Amravati in South India. It was the first city in South India, the first actual capital city in that country to have been built in 70 years. And they commissioned the very prestigious London-based architect Norman Foster to do the assignment. And the architects were using all kinds of tools, and there were myriads of what we call project architects and design architects from different firms, all working on the city. And in order to keep a cohesive vision for the project, the chief minister mandated the use of a digital twin to be able to allow these different architects to integrate all of their 3D models and data into a common framework that would then allow them to simulate the impact of these designs on things like the average street temperature in the middle of summer. Things like wind patterns, et cetera. So we were able to integrate myriads of BIM models, Bentley, CATIA models, Revit models, design, things like GLTF models, and their associated data, and apply this fancy artificial intelligence-based microclimate simulation tool to prove that we could reduce the average street temperature in the middle of summer by as much as 8 degrees. And those of you in the engineering business know what a massive savings that is, not just dollar-wise, but also in terms of carbon efficiency. Later on, we deployed this technology in the United Kingdom on a massive infrastructure project called the East-West Rail Project that runs from Oxford to Cambridge. It's a 103-kilometer project that W.S. Atkins and Lango Rourke and Network Rail and some other major players were involved in creating together. And because it's such a big project that would ultimately take 25 years to build, they wanted a single project data map for the entire thing that would allow us to integrate things like LiDAR scans of the entire site that were taken from drones flying overhead with satellite imagery, with 3D JPEGs, and then eventually allow the engineers to integrate their real-time BIM models such that they would respond to these constantly changing, constantly improving, always updated on-the-ground conditions. It was a fabulous experiment and one project that we're particularly proud of. Other things that we're getting involved with include straightforward real estate and commercial real estate. This is the Orlando Sports and Entertainment District. This project is just to the west of I-4 in Orlando. Everyone knows Orlando for, of course, the theme parks, but now they're developing this wonderful, almost LA Live type project. If you're familiar with the project around the Staples Centers in the United States, it's a mixed-use, a multi-function, entertainment-based development connected right to a major sports arena where the Orlando Magic play basketball. And it's designed to really integrate the sports arena with everything else happening in the city and to make the experience of going to the arena much more of a full day or full weekend experience. In this case, they're using a digital twin for a variety of purposes. One is strictly tenant facing. As a tenant or a visitor, they want to be able to pull information from the twin into a mobile app that would be able to let visitors do everything from wayfind around the facility to find parking, to valet a car, to choose a seat in an arena, to choose a hotel room and see what the view is like, all from a single application. So it's really a kind of 3D virtual tour loaded with data kind of experience that is designed to make all of this much more holistic for the visitor. It's also going to be used to integrate multiple smart building systems, including energy management, tenant security, et cetera, into a single portal. And we've begun to already to do that, in fact, in the model. And in the process of doing that, you can derive efficiencies between those systems and find lags, et cetera, eliminate redundancies, which really kind of draw attention to the power of tools like this. So it's always kind of fun to show some of this kind of in action, as it were. And Smart World itself has been in development for almost, I think, 11 years. It started with the team that famously created Google Earth. After they left Google, they joined our team and created version 1. This is now effectively version 6. And we have gone through this process of iterating and iterating and iterating. But the lessons that we learned were the following. One, unlike most of the other tools out there, we are a combination of a game engine experience and a data science experience. Half the company is really comprised of computational designers with backgrounds in architecture who love gaming, and the other half are raw data scientists and back-end engineers, because most of what happens in Smart World you actually don't even see. And the result is really kind of a very powerful all-in-one platform that can do a variety of things, from IoT device monitoring, which we're going to show you in the first, I think, clip here, to being able to show owners and operators how we can manage information across multiple assets, in fact, even in multiple locations, which will be interesting to watch. How you can perhaps import and annotate 3D models of almost any kind, including building information models, Matterport models, GLTF, and other forms of game engine-based model, all into the same environment. And then how this tool is actually beginning to become kind of a mini design tool itself. We call this kind of mini BIM, and we'll show you what that means. So I'll do a little bit of narrating here. This is the latest release of Smart World that you're seeing. This is called Smart World OS, and this is the work that we've been doing in Orlando with the Sports and Entertainment District. And here we've integrated a number of smart building systems already, including those that monitor heat pumps, air quality, and also even public safety footage, et cetera, all into a common framework. And then we analyze those. We can see their performance in real time, and then the engineers can analyze those and optimize those using a variety of tools that are embedded on the back end, which are part of the overall mission of making the project more efficient. This process continues on an ongoing basis, and we have a single tool from which all of the operators from all the different facilities can commonly work from. Examples here of how the tool gets used when we have multiple assets in multiple locations. Here we're logging into Sydney. I think it is here. Yes, that's right. Where we have an owner that has multiple locations. This one, I think, is on the eastern coast of Sydney. And that same owner may have assets in other parts of the world too. So we're just going to kind of hyperspace to Orlando. And this is Orlando. We can go and then inspect our Orlando properties. We see the location of the OSCD. We can then drill down more granularly into the BIM model itself, where we have all the asset data and all the IoT sensors and all the analytics embedded in that real-time model. We can inspect, we can generate reports, and we can now even, in fact, go inside this facility to see information inside the building, which is really kind of extraordinary. So electrical panels, boiler rooms, et cetera, major equipment we can inspect. And now we've also integrated things like Matterport models. Our work with the US military has brought this into our platform. So here, not only can we integrate these models, we can also annotate them with real data. So that when we're running analysis, we're actually running analysis on all the data inside the Matterport models themselves. And as I mentioned earlier, we're finally getting into the space where we can begin to develop our own models. These are our kind of mini BIM rapid design modeling tools. Not everything you need a BIM model for. Most things you need kind of a simple design model for, especially at the planning phase, which is what this achieves. But it's based on the rules of geometry and physics and can be used and served up into the various analytics applications that we have integrated. So we're almost done here. I wanted to thank everybody for taking the time to hear me talk about Cityzenith and some of the work that we're doing. We are looking for partners in the oil and gas sector. So if you're interested to learning more about potentially being an exploratory partner with us, we'd welcome it. Please do feel free to email me directly and or go to the website cityzenith.com to learn more. Again, thanks very much for having us, to all the organizers, and we're looking forward to a terrific show.